kind of calm me down, whatever. So anyways, let me pick one problem and see what is going on here. And how about if I try one with this yellow and red circles to see how, let's say, problem 53 can be done. And I'm waiting for your questions, of course. That deals with 3 given that a red disk is selected. So probability that we get a 3 given that we are on red. So if we're on red, it means we don't have yellow. So we don't have these 3 circles for sure. So it looks like we have 5 total to choose from, right? Out of 5. So when you have conditional probability, your sample shrinks. And that's what we have in this example also. It looks like there is only one circle that I'm interested in, the one that has 3 on it. So it'd be 1/5, just like that. Of course, we used to have conditional when we repeat experiment more than once, but here they just select one, and that's pretty nice. Let me do one more. Since you don't have any odd problems for me, I can do 59. So we need to find the probability that we have a red, given that at least 5. So at least means greater than or equal to 5. Did you know that at least stands for greater than or equal? That's very popular type of a question, at least in A here. Very popular question in probabilities or statistics. At least means not less. Less than 5 is not permitted. Could be 5, could be more. So at least 5 means that we need to consider the part with 5 or greater. So we're looking at these 4 circles, 4 disks here. And how many of them are red out of these 4? Well, 3. So looking at the picture, we get the result. Conditional probabilities are here. So please do them over weekend. I'm sure that this section does deserve attention. So we'll give you time over the weekend to catch up, do some problems here. And maybe on Monday we can do more from this little section, because that's something that may seem to be straightforward, but I know some people have issues with this conditional probabilities. I also told you not to worry about this last page of this section. There's lots of exercises, so I think it'd be plenty if we do just problems from first groups, first 2 pages. And here's the very interesting statement that may be quite familiar and intuitive in a way, so-called expected value. And what do you expect when you do experiment? And the answer is you always expect the average. So the average, whatever it is what you should expect, especially if you do your experiment a number of times. So let's say if you have chances, well, let's just look at their examples instead of me creating it. So it says that claim an insurance policy pays $200,000 if you become very ill to continue education. So 200,000 is what you can get. But the chances for that to happen is 1 out of 5,000 of those claims. So what do you expect to actually get in average on each of these claims? So if for this 5,000 claims, they pay 200,000 to one of them, but zero to everybody else. Well, they say then the chance that you will get that 200,000 is 1 out of 5,000. So when you multiply, you will get the average of $40, which is what is expected value. I say, how do I expect to get $40? Well, that's what the insurance company expects to pay in average. That's the idea, average payment. And based on that, the insurance company that sells this $200,000 policy will set their policy price, and that should be definitely higher than $40, because otherwise they'll go bankrupt right away. So they can say, we will insure you for, let's say, $100. So just pay $100, and if you get ill, then we'll pay you 200,000. In the case you cannot continue your education. So that should be something serious. So, and then looks like they will actually give average payment to each policy holder of $40, but they will make 60 on every one of them, again, in average. And that's what this is all designed for. The expected value is expected value for them to pay if they have such a claim. So here's another little example for expected value. So we already know this die, right? This little cube with 6 sides. And you roll this cube. We did this so many times already. And you can get any of these 6 sides on the top. And we already know that probability for every single one of them to come up with the same, if it's a fair die, it's 1 out of 6. So what is the average value do you expect to get when you roll this little cube? Let's say if you play in game, and if you're doing this so many times, you roll it like 100 times. So what be the total that you get if you keep adding all these dots on the die? And it turns out you don't really have to do it 100 times. You can say, I can get 1 with a probability 1/6, I can get 2 with probability 1/6, 3 with probability 1/6, and so forth with the same probability. So what you end up with is 3.5 after doing some arithmetic, or just placing it in your calculator. So the average you get on each roll is 3.5. Of course, it's not it's not possible. When you say, Alex, I can get either 3 or 4. What are you talking about? 3.5. Well, that's the average. If you roll it, say, 100 times, then the total, if you keep adding this, whatever you produce on the top of the digest, first roll was 1, second was 6, so in 2 rolls you got total of 7. And another roll you got 5, so total is 7 and 5, 12. So if you just keep on adding those, then the average will be 3.5, let's say, on 100 rolls. So if you were adding them all together, you would have had 3.5 times 100, which is 350, or somewhere in that neighborhood. So that's the expected value. So you're averaging it over 1 roll. So you see what's the expected when you roll it once. So why this is so important? Well, it's important when you're, say, playing a game and they charge you. They say, you know what, if you get more than 3, for example, well, then you get such a payoff. But if you get less than 3, well, it'd be like 0. and they should calculate expected value. And for the expected value, you get more than 3. So they should give you lower payoff because you're expected to get more than 3. So that's the idea. So when you're, again, making payments, again, that's not for you to count, but for casino or insurance company. So they calculate what is expected for you to get over one roll, and then they charge you some particular price to do this game, or to buy insurance policy, or basically just to do anything at all. So turns out that this is nicely clarifiable by tables. So here they describe the experiment that is one of my favorites. It's like when the family has 3 children. I think we already produced 3 diagrams for it, and there were 8 possible outcomes. Remember, there could be either no girls, or 1 girl, or 2 girls, or 3 girls. Like say, what about 4 girls? Well, there are only 3 children. So 3 children, you cannot have more than 3. So, and here are the possibilities. So all boys, or the opposite, all girls, or you can have 1 girl only. So girl could be first child, middle child, or a third child. Or you can have 2 girls, which is equivalent to having 1 boy. So boy could be last child, middle child, or first child. So it looks like all of the possibilities are here. Now, they also put so-called outcomes as number of girls. So you can have 0, 1, 2, 3, or 4, or 3, sorry, 3 girls. And since there are 8 total possibilities, then for the case when there are no girls, we get 1 out of 8. And 3 possibilities out of 8 for both 1 or 2 girls. And finally, another only 1 out of 8 for all 3 girls. So we can see this from our sample. So the question is, what's the expected value in here? How many girls do you expect when you have 3 children in the family? Well, you say, well, I expect to have half boys and half girls. That's what's expected, right? And you can actually see this calculated by multiplying those corresponding values, and this one, and so forth, and add them all together. So when you multiply these and add like they did here, they do some arithmetic and end up with half of girls. I know it's not possible to have 1.5 girls, but probably if there be 4 children, that'd be more intuitively to say we expect to have 2 girls and 2 boys. Of course, it may not happen, but that's what we expect. That's what's the average. Again, if you average over entire population, so we assume there's like half girls and half boys are being born. So it's all being transferred, not just for one family, but for statistics for overall. So that's what this expectation is. And again, it's not what one person expects, but whoever does statistics expects. So I guess that's nice section from perspective that all problems are very, very similar in here. And that's what they're actually talking about in various exercises. It was this, they like to put tables and then to multiply corresponding values. So let me do problem like number 3 here in 11.8. Just clean this a little bit. So you will see that this section, it's a last section, by the way, of probability chapter, is a nice section. One would usually expect the section being challenging if it's a last section, but no, not really. I think it's a pretty nice and a fair section that we see here. And it's straightforward. You just need to multiply the entries in the table and get yourself a nice answer. For example, in exercise 3, that says claim amounts are here. So there is no claim with a chance 0.65, so $0 insurance company pays with a probability of 65. Why do I write 64? 65. The next possibility is they pay about 50,000, and the chances of that is 20%, 50,000. It looks like, again, from perspective of insurance company, how much would you need to charge one family for home insurance? So it looks like they have statistics, how much they used to pay, and they see that with probability 10%, they pay 100,000. Oh, that's a big payment. They actually have other bigger payments, 150,000. Look at that. And they pay this with a probability 3%, 0.033%. Then they also pay 200,000. Wow, that's a lot. 200,000. And the chances of that are pretty low. It's like 0.01, right? And again, 250 they pay. Again, it's one more. 250 they pay with a probability of 0.0. So once you calculate this, you will tell the insurance company owners how much they should charge for the insurance policy. And that's what the actuaries do, right? So they make 100,000 a year, and they do this kind of thing, which is, I don't know, that's not a very hard thing to do, right?
Professor, sorry to interrupt. So we are doing 11.8. It's just because I'm asking because it's not in our syllabus. Like the last section in our syllabus is 11.7.
That's okay.
Ah,
We can
okay.
do that. 0.1 and then plus. So yeah, you notice that I think I skipped some section maybe. So it says it's not exact, but tentative schedule. I looked at this section, I said to myself, Alex, why don't we look at this section together with a class? Because I think that's a very applicable to real life situations, right? And who knows, someone might say, oh, I like this calculation, so I want to work for insurance company. So now I see what is going on behind the scenes, how they calculate the monthly payment on my insurance policy, and that's what I guess they're doing. So here it is with this type of question. So it looks like here's my entire entry that I produce. So $0 is 65 probability, 50,000 is 20. So just double check. And then we have 3, right? 100.1, and then 0.3, and then 0.1, and so forth. So it looks like it's 29,000. And that's what I expect to pay, the average amount. Again, I expect to pay to each person that has my insurance policy, which means that, well, I have to charge more than that, right? And here comes the question. Are people going to buy my insurance policy if I charge them $29,000 or not really? Well, I'm not sure if that's per year, because I know they want you to have this insurance for some time to be opened towards the claims, right? So maybe they want you to keep the insurance for at least 3 years or 5 years, who knows, whatever the insurance companies have in their mind. And based on that, well, they will decide the annual policy price. I think that 29,000 is pretty high price, right? So not too many people will buy this type of insurance. Well, who knows? But that's the idea. So it looks like all you do is just multiply probabilities by the payoff amount or the outcome value. And that's how we calculate what we expect per each occurrence. So if you have a table, it's pretty nice. If you don't have a table, well, then you supposed to produce one, right? Let me try to produce one in exercise number 6 here. Let me do an even problem for you. Exercise 6 that says construction company is planning to bid on a building contract. So the bid costs company $1,500. Let me write it down. 1,500, that's what they have to bid on. And say, why is it so expensive? Well, you probably need to hire some workers and to pay them. So there are various things, buy bond, insurance, some other things. So probability that the bid is accepted is 1/5. 1/5 is the probability that this bid is accepted. Okay. And then what? If the bid is accepted, the company will make $40,000 minus a cost of the bid. So the company will actually make a profit, 40,000 less 1,500, so minus 1,500. So please notice that since 1,500 is what they're paying out of pocket, it counts with a minus. So they're actually losing this money. So the chances that they will lose 1,500 is 1.5, 1 out of 5. And the chances that they will make 40,000 will be actually not being careful. That bid is accepted as 1/5. So the chances that I will make this money is 1/5. But 4/5, that bid is not accepted, right? Well, there are some other construction companies probably also bidding, maybe 5 of them, so that you expect that the probability that you will win this bid will be 1 out of 5 those construction companies, and probability that you're not going to get this bid will be, well, remaining 4 out of this 5. So the question is, determine this value, the expected value on this particular job. And looks like I just have to multiply like we did in the exercise prior. I'm gonna have to multiply these probabilities by, in this case, amounts that I'm gonna earn and add them together. And this will give us what I expect on this particular job, how much I expect to make. And I need to get a calculator, of course. So let us do this. Minus 1,500 times 4/5, 4 divided by 5. And then we add it with, I can put this in the parentheses, I don't have to subtract. I know you probably already subtracted, but just to show you that calculator can take care of it. So you don't have to worry about doing anything by hand if you have a calculator, especially one like this. So here's what you expect to make on this job. When you say, Alex, I expect to make 40,000 less than that 1,500 that I spent for a bid. So what does this mean? Once again, it's in the long run. So if you bid, let's say on 5 jobs of this type, you will lose 5 times your 1,500 and will take just 1 job. So in average for each of this job, you're making 6,500. in average for each estimate that you're producing. So that's what the company owner is probably thinking of. And since every estimate they make is so valuable, it's 6,500 potentially behind it, well, then they probably should spend some money, maybe hire someone to pick up the phone. I know if you ever try to have construction done on whatever, sometimes you call the company, call them, they never answer the phone. So basically they losing potential customer, right? So if your expected value on each job is 6,500, well, then it probably makes sense for you to have hire a person that will be by the phone, maybe give her or him a phone that works pretty well, and make sure that you probably pay that person for helping you not to lose any of these jobs. So that's then something that could make sense quite a lot, right? For a real life situation, just based on a little exercise like this. And that's the reason why I think that this section makes sense to consider. In fact, there is nothing else in this section. So it's this expected value is very intuitive procedure. In fact, in next chapter, we will return back to the ideas of average as well as expected, what we expect as well. So maybe you can do one like that also. How about exercise number 1 for a little quiz for today, before weekend quiz. So please do quiz here. And what you need to do is, well, just calculate expected value. Maybe I should scroll this a little bit so you can see what they ask. Okay, so the quiz will be exercise number 1. And the way to do it, just look at how I did the other 2 problems. It's exact same number of steps, and you multiply corresponding values and add them from your little table. And that's all you need to do, right? So I'm going to stop recording.